For this lesson, you will need page 32 to 35 from your workbook, a pencil, and a calculator. We are going to study trigonometry. Trigonometry is a branch in math that deals with triangle measurements. When we work in trigonometry, we need to know something called the sine and cosine ratios. This has to do with the relationships between the sides and angles in a right triangle. So let's review how we can actually name the three sides in a right triangle. Let's start with the longest side across from the right angle. If you remember, this is called the hypotenuse. If I fix an acute angle, call it angle X, the side across from angle X is your opposite side, and the side next to angle X is the adjacent side. When we talk about trig or trigonometry, you want to remember SOHCAHTOA. Sounds funny. Well, it's actually very useful in helping us to remember that what mathematicians decided to call sine of angle X is the ratio between the opposite and the hypotenuse. That's why it's S for sine, O for opposite, and H for hypotenuse. Similarly, cosine X is chi. So guess what? Cosine X is A adjacent over H hypotenuse. And the third trig ratio is called tangent. So from TOA, we know that tan X is O for opposite over A for adjacent. So let's see how we can apply this to solve some triangles, to find missing lengths or missing angles in right triangles. Example 1. Find the length of side AB to the nearest tenth of a centimeter. The most important thing for you to do when you do a question like this is to make sure you know which sides we're talking about. So in triangle ABC, the 11 centimeter or side AC is the longest side, so this is the hypotenuse. X is side AB, across from the 37-degree angle, so this is the opposite side. So let's think. OH, opposite over hypotenuse, is sine, so we can now write sine 37 degrees is equal to X over 11. We want to find out what X is, so let's cross multiply to solve this equation. X can be written as 11 sine 37 degrees. And now take out your calculator and enter 11 times sine, so it will be a button, S-I-N, 37 equals. Round your answer to one decimal place for tenth of a centimeter. You should have X approximately equal to 6.6 centimeters. So let's try the next two questions. Find X to the nearest tenth of a centimeter. Triangle A. We have the 33 centimeters across from the right angle, so this is the hypotenuse. From 51 degrees, X is across from it, so we have opposite. So opposite hypotenuse again means X over 33 is sine 51 degrees. Cross multiply the 33, X is equal to 33 times sine 51 degrees. Using a calculator to simplify this, you will find X is approximately 25.6 centimeters. Triangle B. So let's see what's different or similar in this triangle. I see the 35 meters. That's my longest side hypotenuse. Now, the angle 50 degrees is right next to side X. So instead of labeling side X as opposite, you should be calling it the adjacent side. So saw, ka, toa, I can think of ka when I see A and H. So X over 35 must be cosine 50 degrees. Cross multiply to solve for X. X is 35 times cosine 50 degrees. Try this on your calculator. Did you get approximately 22.5 meters for X? Now you have to pay attention here in case you have not been successful in getting these numbers, even though you followed all the steps outlined in the video. Take a look at the screen on your calculator. Does it say D or DEG for degree, or does it say something else like grad, rad? If that's the case, your calculator is in the wrong setting, and you can press the mode button or the reset button on the calculator to fix this, to make sure your calculator is doing all its calculations for these trick questions in degree mode. Okay, so let's go to the next page. Well, instead of using SOHCAHTOA to find missing lengths in right triangles, we can also use it to find angles. So let's use this example to show us how we can find angles using SOHCAHTOA. A storm caused a 13.5 meter hydropole to lean over. The top of the pole is now 11.8 meters above the ground. Find the measure of the angle between the hydropole and the ground to the nearest degree. So this diagram shows exactly what the question talked about. Notice how when we talk about the height of an object above ground, we can assume that this is a right angle, and 13.5 meters is the hypotenuse, while the angle between the ground and the pole is marked angle X here, and so 11.8 meters is the opposite side. So this is the very familiar ratio again. Opposite over hypotenuse is SOH for sine X. So sine X is 11.8 over 13.5, but there is no such a thing called let's divide by sine to solve for X in math. Instead, we'll be using something called the inverse sine or second function sine on your calculator. To do that, you may want to first simplify 11.8 divided by 13.5 on your calculator. Keep this number on your calculator, 0.8741 ... And then we can isolate X by calling out the inverse sine function. The symbol for inverse sine is sine with a superscript -1. Looks like that. And now on your calculator, enter shift or second function plus the sine button 0.8741 equals. And that should give you approximately 61 degrees. which means that the hydropole forms an angle of about 61 degrees with the ground. And you can write the sentence. Sorry. Let's put this in. Okay. You may also want to write down the notes to remind yourself that in order to find angles using trigonometry, you will have to use something called the inverse trig, such as sine -1, cos -1, and tan -1. Okay, let's try another similar question to practice using these inverse trig functions. Find the measure of angle K to the nearest degree. My hypotenuse, 24 centimeters, is here. Angle K is highlighted. 15 centimeters is next to angle K, meaning that it's called the adjacent side. Adjacent hypotenuse is CA for cosine. So cosine K is 15 over 24. Follow the similar steps in the previous example. Cosine K is 2.625. And now to find angle K, you are going to use second function cosine or inverse cosine of 0.625 to get angle K equal to approximately 51 degrees. So this is the end of the lesson, and now you can move on and use your class time productively to work on pages 33 and 35, numbers 1 to 5.